Hi. So I want to talk to you about my approach to computing. I've been fascinated with programming since an early age. And the first few languages I learned by doing. Like, I wanted to make a game, print something. I just found out how to do it and then did it. And then new languages came and new ways to do things and shorter ways to write programs. And after a while, I started asking myself, like, is there a difference between these? Or what is the common thing between all these languages? Is one better than the other? And so my great quest began to find the one true language. One language to rule them all. One where I could express ideas concisely in just a few lines of code. Where I couldn't write programs that crashed. And that was still somehow simple and easy to understand. Well, as you can imagine, I haven't quite gotten there yet, but after a few dozen languages, well, we're getting close. And the other way around, this means that I don't let my programming get in the way of the language, which is why I work part-time. All right, so while searching for this great language, I ran into a great big problem, and that's the JavaScript problem. It can be concisely summarized in this one point. Yes. So, JavaScript sucks in many ways, and it's all well documented, and I really don't want to bore you with it. I'll just show you a few examples of it. For example, what do you think this is? Well, let's just see. Oh, why, of course it's object, 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 object. But that's not all it is, because if I open it in a browser window, it's nan. What? I guess that's just some difference between implementations in JavaScript. Oh yeah, that too. So I'm just going to evaluate these real quick so you can see the problems with this. In short, dynamic languages like JavaScript, Python, Ruby, Perl, PHP, all the others, when given a choice between doing something that doesn't make sense or not doing anything at all or throwing an error, they usually pick the first one. Like, okay, let's add a list and a number and make like this. What? All right, and there are more subtle problems, of course, like the problem with this. This is not like in C++ or Java, somehow tied to the object you're working on. This is actually set when you call the method, and it's set by this dot. So this is a method call, and it sets this to O. And this is a function call, and sets this to window. And of course, that causes problems, like you can't really set methods as callbacks, because they're not going to have this. And there are some related problems as well. For example, when you have a for loop and a variable, and you pass a callback that uses that variable, well, in short, it's not really going to be what you expect. Let's see. So this is going to print 555. Because, well, this I variable gets updated in every run of the loop, and, well, there's nothing to account for that. So the solution is to wrap this function in another function where you pass I. There. I think. Right. There you go. Well, you get the idea. Right. Besides this, there are many problems with the language, like a useless for in and with construct, object-oriented programming being very hard to do right, and immense need for best practices and ways to avoid common mistakes. And it also has a very poor specification, and the incompatibility arising from different implementations, browser, node, all makes it worse. And on top of this, there's no module system. You can't really tie pieces of code together, make them work together in a meaningful way. So there are just like hacks, like put everything in the global namespace, put everything in window, or use one of the 5 different kinds of module loaders available. Okay, so that's that. But we also need JavaScript because it's the only thing that runs pretty much everywhere, and most importantly on browsers, and we need to program for the web because it's one of the major platforms. Because I'm not just theoretically interested in the language, but in a practical way, in a way that I actually want to use it to like do stuff. There are some good parts to JavaScript, and there's a very rich media interface that is the browser around it that you can sort of use if you work around the differences on it. All right, so during my years of searching for this perfect language, I found a few properties that I would like it to have. I'll talk about those in a bit, but the solution to this JavaScript problem is, well, a language that compiles to JavaScript, which is a proven approach. CoffeeScript does it, although it's not really complex what CoffeeScript does in this area, and there are many, 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 many more languages that compile to JavaScript. Here are a few. And as you can see, also many existing languages like C#, Scala, Java, whatever, Python, sort of compile to JavaScript. Very few of these are in widespread use, like maybe somewhere under 10. So this solution lets us have all the advantages that JavaScript offers us, which is basically running everywhere and having a browser at your back for all the good and bad that means. And it hides, like, there is a possibility to hide all the ugliness of JavaScript because, well, you know, before I asked if all the languages are actually the same, and in a certain way, in the sense that they're all Turing-complete, so you can express exactly the same kind of computations in all Turing-complete programming languages. They are the same. So, yeah, you can compile any language to any other language, but in this case, we want to target JavaScript in a way that makes sense and in a way that we can use it well in browsers. All right, so this ideal language that we're looking for has these very nice theoretical properties. It's consistent. I like my languages consistent. I don't want them to cause, to be in a state that is contradictory. I don't want my program to throw exceptions when it runs, and I don't want my program to cause type errors when it runs. Possibly only if a user clicks in a specific area with some numbers. All right. I'd also like my language to be abstract, which means it has good facilities for abstraction, for picking out the common parts of algorithms of code, and then composing them all together, putting them all together I'd like my language to make this easy so I don't have to write code several times for several different but similar cases. And I'd also like my language to exist, which is the last point in this section. All right, so in order to find this language, I will have a deep truth to guide me. And that is the basic truth that everything is somehow connected. According to the Curry-Howard correspondence, two specific instances of logic and computation are not only very similar, and they sort of have this, like, you always knew that like math and programming has something to do with each other, but this is stronger. This theory states, and it's proven by the fact, that they are in fact isomorphic. There is a direct translation between propositional logic and lambda calculus, which is a form of, it's a basic programming language that is Turing complete, and also isomorphic with the Turing machine. So that's a basic truth. And that this theory was also expanded to include math, to include category theory, which is, well, some abstract nonsense that underlies all of mathematics, like set theory, like pretty much most of algebra. So it's somehow all the same. And that means we can use the advances that we made over thousands of years in logic to help us with our programming, to help us avoid bugs. All right, so this is the truth I'm going to use in the search for the right language. And I'm going to present to you the features that are sort of present in the ideal language, and I'm going to show you how PureScript implements these features. So, I'd like my type system to be static, which means that I'd like to know before a program runs what kind of result it will give. And not only that, I will also know what the type of each variable is. This is pretty basic. I mean, if you've developed in C, C#, C++, Java, and all the other languages, this should be familiar to you. Now, usually this gets in the way, but I'd like to use this as an advantage and to make programming easier, not harder. And now I'm going to have to ask you how many of you have programmed in Scala, Haskell, OCaml, or F#. Please raise your hands. Wow, I'm going to have to do some explaining, I guess. All right. So, I'm going to do a demo about these types real quick, but these basic facts about the type system that I would like and that PureScript has, besides being static, so knowing all the types in advance and stopping errors from happening before you even run the program. There should also be it shouldn't have like these weird automatic conversions between types that like it in very rare instances helps you or makes the code shorter, and it gives ample opportunity for errors to happen. And I would also like to have my types inferred. That means that the compiler sort of guesses what the types are. You've seen most of these features in well, for example, Swift, the first presentation in this in the series, and some other languages as well. All right. So I'd like to have algebraic data types. What that means is you can define exactly what values a type can have, and it's usually a conjunction of values. So you can have either one value or another value, and I'm going to show you some code. Types. Right. So here's a way to define a Boolean type. You can do this, but it's already defined for you. So it's just the name of the type and the two possible type constructors, the two possible values of it. Okay, that's easy. You can have 3 cases as well, sure. And what's even nicer, these types can be polymorphic. For example, in this type, in this maybe, this is the option type, or nullable, if you know it as that. It's just defined like just any other type. You can have, so this type depends on another type. So you can have a maybe int, or maybe string, or a maybe int, or maybe list int, or something like that. So you can have all these types. That means types are polymorphic. They don't just have like one fixed shape. They can have holes in their shapes where other types fit. Here's another example. This is how you would define a binary tree. By the way, if you have any questions, you can ask right now. And if I'll cover these later, then I'll just say later. And otherwise, I'll just show you some code that like probably answers your question. So yeah, go ahead if you have any questions. So yeah, this is how you would define a binary tree. Binary tree is either a node that has 2 subtrees, the left subtree and the right subtree, or it's a leaf. Then you can build trees like this here. This is a tree of maybe number. So as you can see, this type is also polymorphic. It depends on this type A, which in this case is instantiated as maybe number. So you can have a tree where the leaves are maybe numbers. There's a little function that demonstrates pattern matching. So this getLeafValue function takes a tree, and if the tree is a leaf with a number, then it will return just that number. And if it's not a leaf, it's a node, then it will return nothing. Or if it's a leaf of nothing, then it will also return nothing. And this is just like a more advanced switch. The difference is you can bind variables here. So if you put a variable name in a pattern, then you can use that variable on the right-hand side of the pattern. All right.
So can we add some contrast between the background and the characters?
Can you switch off the lights in the front? Maybe?
We can.
Yeah, you can try. I can make it bigger. You like it bigger? Right. So those are the basic features of the types I'd like to have. And also another nice and well-tested and well-proven feature, thank you very much, is our type classes. Type classes allow you sort of to do what interfaces do for the statically type imperative object-oriented world. You can define functions and that have specific types, and then if the function is implemented for a specific type, then like you can do it, and you don't have to have neither the definition of the interface. You don't need to modify the interface, and you don't need to modify the original type. I'm going to show you just how to do that with type classes. Here you go. So here we define a type class noise that says that my type can make a noise, and that noise will be a string. So if I define a cat data type, which has just one type constructor, cat, maybe here one kitten, then I can even if I don't have this access to, even if I don't have access to this original type, cat, or this noise, so I can't change it, I can add this noise function to the cat. So when I implement the noise cat type class, I can call noise on all kinds of cats. And I can do this for numbers as well. So I can define a noise instance for a number, like num. That's what it says if you call it on a number. Let's see the output. Right, I forgot something, I guess. Right, so type classes make it easy to do sort of ad hoc polymorphism between types. You can implement the interface, so sort of interface the type class for any type you'd like, if it fits, and then it gains new functions.
Márton, you mentioned that you would like to take questions as they appear. There is one question on the Twitter wall.
All right.
Can you check, please?
What's the relation with Haskell? Yeah, very good question. PureScript is implemented in Haskell and is very similar to Haskell. It's also pure, but it's not lazy. Yeah, that pretty much sort of covers it. It's sort of a proper subset of Haskell and safer. All right. So another interesting feature that is very nice, especially in the dynamic language context, is polymorphic records. Records, we all know record types. They're like sort of these objects. So that I can define, say, Chuck, who is a first name, last name, age. And in PureScript and in other statically typed languages, I can define a type for Chuck. And this type is person. As you've seen, Chuck has an extra field here, age. And the polymorphism in the record polymorphism means that you can still call functions that expect the first name and last name fields from a person if there are any extra fields, or if the fields of the record you're calling the function with are subtypes of the original record that the function was defined for. So this makes it easy to use JavaScript objects. By the way, records translate directly to JavaScript objects in PureScript. All right. And purity. Purity is a way to ensure that you can always trace where a certain piece of data comes from. You always know where a value is produced. It never happens that like one piece of code makes a variable and some other unrelated piece of code somehow changes it before or after something else reads it, and then you get problems for that. A pure function can do nothing else but return a result based on its input arguments. It cannot, and the closure, so the variables around it that it can see. It cannot change anything outside the function, and it cannot do stuff like write to the console or change the DOM in the browser. And I'll get back to this because if we want to actually do stuff with a programming language, we have to do those kind of stuff as well. And the values in PureScript are immutable. You can't change a variable after you've first declared it. And these features together allow you to like trace what's going on in your language. You can also always trace just by looking at the code what's happening and what comes from where. Right. There's an alternative to Purity that I also accept. It's implemented in Rust. It's called linear typing. It basically means that if you change a variable, you can only use it locally, and its effects don't sort of bubble up and affect other code. That's also nice. Yeah, and well, syntax, they say syntax doesn't matter, but if it's mostly noise like curly braces and parentheses and function and var and all that kind of crap, then, well, it's sort of, it's not that I'm lazy to type. Well, yeah, I'm lazy to type it, but I'm lazy to read it. I mean, don't want to read the same thing over and over again when you can sort of abstract it. But a language that allows great abstraction usually doesn't have problems with these. All right, so yeah, we can go on. PureScript is a language that compiles to JavaScript and has all of these features, except one that I didn't mention that I would really like to have. But there's another language for that, but it doesn't have the browser support anyway. And PureScript is designed for browser use, but also works very well on Node. And it has a really good community and libraries to get you started. You can draw on the canvas and stuff. Maybe here's a demo of it. Here. As you see, this project is used for serious software, right? Seriously hard. Here we go. So, well, yeah, it works and you can use it now on the browser. So that sort of checks out the last point I needed in my ideal language. And it's very JavaScript compatible. It generates readable JavaScript output. You can sort of, if you read the JavaScript output that's compiled, that PureScript is compiled to, you can understand what's going on. It works everywhere. There's no runtime system, so you don't have an extra, like, I don't know, like 10,000 lines of JavaScript code that you have to load in order to be able to run your PureScript programs. And it's really easy to communicate with JavaScript. So the way you do it is you just do a foreign import. You specify the JavaScript function in a string, and then you give it a type annotation. You say what type it is. Then you can use it like this, just like, or. Right. So as I said, the community is, well, existent and useful. You can just, if you have any questions, you can just pop on Eric and talk to some of the developers and like other people that just hang around there. There are a few good libraries as well, for anything from like rendering on the canvas, doing asynchronous network requests, and yeah, lots of data structures and manipulating the DOM. And there are some very interesting libraries that make use of some theoretical research done on well, user interfaces and the programming language theory behind them. And one of these is PureScript Halogen, which uses a form of functional reactive programming, and your user interface will be a pure function. And you also have a nice way to write asynchronous requests and to escape from callback hell. Oh yeah, and there's an experimental C++ backend that has very high hopes. So you can finally run, well, everything everywhere. Okay, let's see maybe some more code examples.
Márton, there are again questions on the Twitter wall, if
Sure,
you
go
would
ahead.
like to treat them. So, first question is asking, have you measured the performance for a moderately large project between PureScript and JavaScript?
Excuse me? Performance?
Performance compared to JavaScript for a reasonably sized project?
Well, you can read the translation to JavaScript is very straightforward. Objects translate into objects, and function calls translate into function calls. So you're probably going to have a few extra function calls because it's a functional language. But otherwise, it should be all right. Of course, there's a performance hit because of the purity. If you can't really update arrays, you can actually, if you really want to. It has unsafe functions. But there's going to be a performance hit for that, but there are other data structures you can work with, and if you really need to make it fast, then you can just like write that part in JavaScript anytime, and it's extremely easy to do that. So I wrote a sort of complex library that translates arbitrary JSON into a table. I'm going to show you in a bit. Try it. Here we go. Need an example JSON as well, it seems. Perfect. So you take any JSON you want, and then it sort of, what the hell is this? And then it generates a table for you. Apparently, this JSON is not very well structured, but you can use any JSON, and the structure appears in the headers. So I think you can't see all the vertical lines in this table, but the glossary is the main item here, and it has like subfields like title and gloss div, and those are all put into the header here, and the values are all inside the table. So and I ran this with like really big JSONs, and it works. It's not very slow, so yeah, should be okay.
Do you mind continue attending the Twitter wall because there are questions flowing in?
Excuse me?
Do you mind
more
attending the Twitter wall?
go on.
Yes. So speaking of JavaScript, what do you think about Douglas Crockford's JavaScript, the good parts?
Excuse me?
I guess there is a paper by a gentleman called Douglas Crockford titled JavaScript, the good parts. And basically the question is asking your view about this paper.
He mentions first-class support for functions. So functions are values. You can sort of pass them around, put them in a variable, and they capture the variables around them. So if you can use variables that were defined outside a function from a function that you pass as a callback, and that's all fine and nice. But problems start to arise when you add mutability in the picture, and where, for example, the for loop I showed you, it sort of just changes the variable, and by the time you access it, it's not the same anymore. It's not the value you wanted. Go on.
Next question is asking whether for PureScript there is anything like the Angular framework for JavaScript.
Yes, there is a front-end library. It's called Halogen. It's the one I mentioned earlier. And the idea here is to have your whole user interface as a pure function. So you define example, here. You define your inputs. Here it's just one click, and then you define a render function, and also add the event handlers. All those are managed in a type-safe way. So you can't listen to events that don't exist, or even you can what you can't do is like change an attribute or change an HTML element that doesn't exist in your page. So checks can be added but they don't have to be added for all that. They're sort of built in. They're assured by the type system. As I told you before, there's this isomorphism between logic and programming, and the exact way that this analogy works is that types in your program are like theorems, and the program that you write is the actual proof that those theorems can be satisfied. And in statically typed languages, that is sort of exactly what you do. If you write a proof that is wrong, the compiler will reject it. The compiler is like, it checks your proofs based on your theorems. So, yeah. Go on.
Okay. There was a question earlier asking for an example of how the JavaScript code looks like, which is actually compiled from PureScript.
Oh, yeah. Very good. Let's take a look. Let's compile this, for example. I think I have this right here. Here we go. Let me just... Here. Source compiled. It's a little bit more complex. Like you have more vars added in and some extra constructs, some more function calls, but you can sort of look at the JavaScript code and understand what's going on and what came from where. Also, and I thought this was very important because a lot of languages that compile to JavaScript have really terrible output, and you really can't use it to debug at all. But what I found when developing with PureScript is that you really don't even need to look at the JavaScript output because it never crashes, so you never need to see a stack trace. There are type errors at compile time, though. Yeah?
And last question on the wall currently is how does it feel to code in one language, PureScript, and then debug in another language, JavaScript?
I addressed this question. So there's like, you can make it crash, you can make it throw a type error, but it's hard. And the whole point is that this doesn't really happen. And because, this translation is straightforward, so it's easy to debug. You can actually add breakpoints to the produced JavaScript, or you can add debug output, what have you. The point is, you don't get exceptions, you don't get type errors. Your program will not stop once it starts, usually. So it's not really a problem. There's one more thing. Why do we need another language like that? I mean, I showed you like the list with about 100 languages, that just the ones that compile to JavaScript. Well, I looked at a lot of them, and a few came close. But all of them somehow fell short of this ideal mix of theoretical beauty and elegance and usability and let's say sort of simplicity, because PureScript is not a very complex language. You don't have object-oriented programming added in the mix, just the features that I showed you. But these features make for some very interesting combinations, and once you begin to explore that, well, there are many possibilities and you have a lot to learn. But just like Haskell, if you've started learning that. but the number of base features is very small, and you can always figure out what's going on if you just like substitute the values and trace the execution.